Hello, everyone. My name is Damien Wiley. I'm here to provide an introduction to the new service that we launched at reInvent a few weeks ago, Amazon Managed Streaming for Kafka, abbreviated as Amazon MSK. All right, so this is what we're going to cover today. We're going to start very high level and talk about what real-time data is, or also known as streaming data. We will touch on Apache Kafka. We're not going to go into a great deal. Our assumption is that you understand what Kafka is and how it works, but we're going to cover a few basics of Apache Kafka. We'll run through in great detail the service itself. We'll walk through what is currently available in preview and what is coming for GA. We'll do a quick comparison to Amazon Kinesis data streams and MSK because both services are supporting streaming data use cases. We often get questions from customers. When should we use one or the other? And we will close with a Q&A session. Data comes from your applications. It comes from logs. Comes from your web servers. It comes from EC2 instances, and those devices and servers and other machines are producing data continuously. Data is not produced in batch. So why should customers have to process data in batch when it's generated continuously? At the same time, data can be transformed continuously. It doesn't have to be transformed when it's inside of a data store. Hours or days after it was generated. It can be transformed within milliseconds of it being generated, so that you can actually take advantage of processing that data in a format that is required for your applications. At the same time, data, its value diminishes over time. If you think about it, the most recently generated data is typically the most valuable data to your organization. So why not mine that value immediately within milliseconds of it being generated, rather than waiting for minutes, hours, or days to get value out of the data? And this is what Apache Kafka is all about. It is all about providing customers with a very powerful tool for processing data, for gathering data, and then processing it in real time, so that customers can build new types of applications on top of data as it is generated continuously. At a very high level, Kafka is a pub-sub architecture, but it's much more than that. It enables many applications to produce data and drive that data into Apache Kafka, and at the same time it enables many applications to read from that data in real time as it is generated. That data can come from any type of device. It can come from a website, it can come from a server, it can come from IoT devices, you name it, Apache Kafka will take it. The way that Kafka is architected, it enables your applications to read data in the order it was generated within milliseconds of it being generated. And that enables your applications to process it and transform that data in real time, either within the application itself, or if the end result is to then send that data downstream, say to your data lake. Apache Kafka provides that first initial capture and transform capability that is required for your end-to-end solution. These are some of the most popular use cases that we see in the data streaming space. First is real-time web and log analytics. Customers have websites and they want to understand how those websites are performing, how their users are interacting with those websites in real time or even in near real time. What they want to do is capture all of that data and then process it later on. Apache Kafka provides that ingestion mechanism that scales so that you can capture web and logs as they're generated, and then have applications on the backside of Kafka reading from it in real time. Messaging is another popular use case for Kafka, where applications are using Kafka as a buffer to communicate so that they're not coupled. It is often used as a queuing mechanism between applications, but it also provides customers the capabilities they need for the analytics on top of these queues. Apache Kafka is used for gathering transactions and also for event sourcing. So if you have many devices, many databases generating change logs or events in real time, Kafka is used as that medium to capture those events as they are occurring and ensuring that the order is maintained and the transactionality of those events is also maintained so that the applications that are reading from Kafka have a full view of what has happened in the order it happened. Kafka is also a popular data store for microservices. So if you're building a microservices architecture within your organization, many customers use Kafka as that data store for those microservices to serve those applications' data needs. And finally, streaming ETL is another very popular use case for Apache Kafka, where customers they're ingesting that data and then transforming that data in real time continuously as it is generated, and then delivering that data downstream to another application or a data lake or a data store, rather than waiting for hours to transform that data. They're doing it in real time using applications on top of Apache Kafka. Let's go a little bit deeper into how Apache Kafka operates. And you'll see here on the left side we have producers. Those are your web servers, your IoT devices, etc. The cluster that Kafka runs on is in the middle, and then on the right is the data consumer. Those are the applications that are reading data from Kafka, that are performing the analytics, doing the transforms, moving data from the Kafka cluster onto a destination. Within Kafka, you have it operates as a clustered framework, in that it is run on multiple brokers, and a broker is a storage node that producers write data to and data consumers read from. And within those brokers, you have a unit of parallelism called a partition, and that partition stores data in the order the data was generated, and also provides a certain amount of retention capabilities as well. Kafka automatically replicates data, or can automatically replicate data between partitions for you. So if you set up your Kafka topic to replicate data between brokers, Kafka will automatically do that by taking data from your partitions or replicating them to other partitions. Apache Kafka uses Apache Zookeeper as a state store for the consumers and the cluster. And that state store is typically run on its own standalone cluster. Within Apache Kafka, you have a logical grouping of partitions, and that's called a topic. And producers write to topics, but they write those writes are in a key value format, and they go to partitions. The actual data is stored on partitions within topics, and each partition provides you with the storage capability required to keep your data in order over a period of time. As you can see here, you have writes from producers all going to different partitions within a topic in Kafka, and the order is maintained, and also those records are also retained for a specific period of time. On the flip side of Kafka, of the Kafka topic and these partitions, you have consumers that are reading data in the same order the data was generated, and they're going from oldest to newest. And most commonly, the consumers are at the reading the most recently generated record. As you can see in the case of partition 1, the consumer is effectively caught up. It's the next record it's going to read is the next record that came in, which is record 5. And in the case of partition 3, that consumer is a little bit behind, and its offset is a stage to read the next record 1, but it will most likely would catch up in this scenario. Now let's talk about some of the challenges that our customers have faced when they're running Apache Kafka on their own. First, Apache Kafka can be difficult for many customers to set up, especially if they're not accustomed to running their own distributed infrastructure supporting Kafka. And setup is pretty easy and quick if you're just running a POC and you just want to get a Kafka cluster up and running, and you have producers and consumers that are reading and writing and reading from Kafka. But the real challenge is setting it up for production. And what that means is you are monitoring your brokers within Kafka to make sure that if a broker fails, you're maintaining high availability by replacing those brokers. The same goes for the Apache Zookeeper nodes, that you have the monitoring and the automation that's set up to replace those nodes when they fail. And if there's patches that need to be applied, that you have the team and or the automation in place to apply those patches seamlessly without downtime. At the same time, you may also want to upgrade your Kafka installation on your brokers and Zookeeper nodes in order to support the latest and greatest changes, which also requires development and automation to set up. All of this requires you to keep an eye out for those edge cases that will create unavailability within your cluster. If your brokers are not there and you don't have data that's being replicated across multiple brokers, that can generate a case where you are not running in a highly available state. So all of this requires a lot of time, a lot of automation, a lot of development effort for your teams just to get the cluster in production state. At the same time, Kafka doesn't provide a console out of the box, and it doesn't provide metrics that are also in that console, so that you can understand if the cluster is healthy, or if your producers and consumers are writing and reading data from topics as you intend them to be. It's also tricky to scale. If you add brokers to Apache Kafka, because you have to orchestrate some partition reassignment where those partitions that the producers are writing and reading from, those actually have to be migrated to the brokers after you've added a broker to a cluster. You also, when a scaling event does happen, the scaling events, like when the partitions are moving around from one broker to the next, those events are visible to the client. So you could actually see performance degradation when the cluster is scaling. If your applications need to be integrated with another AWS service, either for a core data plane integration or for a control plane integration that you would like to see within the cluster. All those integrations you need to build on your own, typically, if you're running Kafka on your own. And then finally, what we've seen is customers' usage of Kafka is always a function of the amount of talent, the site reliability engineering talent that they have on site or have hired otherwise. And otherwise, if they don't have those engineers, they need to ramp up engineers in the skill of operating, maintaining, and keeping Kafka highly available. And a lot of times those engineers are software developers that would otherwise be allocated towards building applications that are closer to the business's end customers. Now, those are the challenges that Amazon Managed Streaming for Kafka solves or will solve over the next short period of time. And Amazon MSK is a fully managed, highly available, and secure service for Apache Kafka. It is now available in public preview in the US East region. Getting started is very easy. First, you go to the console, you specify some VPC settings that allow you to connect your clients that are running in your VPC to Kafka. Within a few clicks, you can get a cluster running in a few minutes, and the experience is also provided through a CLI in the AWS SDK. So you have a couple of different options for provisioning Kafka. It's fully compatible with Apache Kafka version 1.1.1, and that means that applications that are also compatible with Apache Kafka 1.1.1 will also be compatible with clusters in Amazon MSK. We'll be adding support for other newer versions of Apache Kafka 2.x when the service is generally available. When you provision a cluster behind the scenes, we are provisioning and setting up everything for you. So we're installing Kafka. We're setting the AMIs. We are attaching the resources required for bootstrapping, etc. Creating setting up the automation that's required to ensure that your brokers and Zookeeper nodes are replaced if there are issues. At the same time, these capabilities allow you to create and tear down clusters on demand. So if you have dev and test use cases and you just like to spin up a cluster for a short amount of time, you can do that really quickly using these tools. And another question that we receive quite frequently since we've launched is, hey, give me access. Well, access is open to everyone. You don't need to be whitelisted to get started with Amazon MSK. You just go to the console, search for MSK, and you can create your cluster in minutes. Let's go a little deeper into what the service provides. In preview, the cluster lifecycle is fully automated. That means that the brokers and the nodes are automatically healing themselves. If the service detects issues with them, we will automatically replace those resources for you. During that replacement, the IPs of those resources remain intact. So if we introduce a replacement resource, the IPs that are used for the clients are the same. That means that their clients themselves don't have to do any work to recognize any new IPs that may have otherwise been given back if we gave you a different IP associated with those resources. The patches are also applied automatically. You don't have to think about patching of the actual infrastructure. We're taking care of that for you. When the service is generally available, you can expect a service level agreement with it. The specifics behind that are TBD, but that's something that we are planning for. And you'll also have the capability to upgrade the versions of your clusters. So if you start today with version 1.1.1, you'll have the capability to upgrade that cluster using the console or the API to the latest version that we support, which will be some permutation inside of Kafka 2.x. Zookeeper, it's fully managed. You don't have to think about it, and it's also included with each cluster you provision at no additional cost. It's highly available, which means we are provisioning multiple instances of Zookeeper across multiple availability zones. Your clients can still connect to it, but you don't have to think about any of the heavy lifting that traditionally comes with managing Zookeeper. Data transfer within the cluster is included at no additional charge. You still pay for the data into the cluster and the data out, but if you are replicating data across multiple availability zones and you're using replication, there's no data transfer costs associated with it. It's all included with the cost of the service. When the service is generally available, you'll be able to add, you'll be able to scale the cluster by adding brokers, both of the same type and even of different types. So if you want to scale horizontally, you can. If you want to add more brokers that are larger, you'll be able to do that as well. And these controls will also be available in the console. Today, the console provides a preview-like experience where we have a set configuration that allows you to just get started with a few clicks, but we'll also allow you to change the instance types and the broker storage as well within the console. You'll also have the capability to define custom cluster configurations. There is a defined configuration that we're applying in preview for every cluster that is configured, created, but you'll have the capability to configure, provide your own configuration for the cluster, upload that, and we'll take that as the input for spinning up your cluster. We'll also auto-scale your storage for you. So if you have, let's say you have a 1 terabyte drives assigned to each broker, and you're running out of space on those drives, we can automatically scale up those drives up to 16 terabytes for you. So that means your applications can continue to write and read from Kafka without having to worry about the data storage running out on the brokers themselves, at least up to 16 terabytes. And finally, as I mentioned, we'll be supporting Apache Kafka 2.x, some version of 2, and you'll have the capability to semi-automatically upgrade on your command. What we'll do is perform a rolling upgrade across the resources within the cluster. We'll take one broker down at a time, and if you are running a highly available, if you're running Kafka in a highly available way, your applications that are writing or reading from Kafka should not see any downtime throughout this process. During preview, we have a number of integrations that are already there. The core ones are Amazon VPC for network isolation. All of the traffic that is driven to and from the clusters in Amazon MSK is over a private connection. That means that there's no public endpoints. We don't provide any support for public endpoints. The clients themselves have to be either inside or connected to your VPC in order for you to drive data to and from the clusters in Amazon MSK. You have encryption at rest capabilities using KMS, so you can bring in your own KMS CMK, and we'll encrypt all the data coming into the clusters, and when it's stored, it'll be encrypted at rest. We have the capability to use IAM for for control plane API authorization. So those are the APIs that you would use to allow your users or applications to create and manage the clusters themselves, and tell us how many brokers and storage and how much storage you need. Out of the box, the metrics from Kafka running on MSK are driven into CloudWatch, and there are two tiers of metrics. You have a standard tier that's free, which includes a number of broker and Zookeeper metrics, and then there's enhanced metrics for topic level metrics. We're using Amazon EC2 M5 instances as brokers. You can choose from large to 24XL brokers, even in preview. And we're also supporting EBS storage for broker storage. Today it's offered in US East, but during preview we might offer a couple of other regions as well. But our goal for GA is to offer Amazon MSK worldwide. There's a couple of other integrations that we are building. Actually, one of these, AWS CloudTrail, is already live within preview, so you should see that now. The others are tagging and CloudFormation. We'll be building those integrations during the preview period. Let's talk about compatibility. If you're running Kafka today and it's compatible with, your applications are compatible with 1.1.1, then your application should also be compatible, or will also be compatible, with clusters in Amazon MSK. It provides native compatibility for Kafka APIs and the admin client. Also, third-party tools and other frameworks that you might be running within your organization on top of Kafka are also supported. There are a few cases that are not supported, and those are the ones. Those are the tools that upload jar files, and we list those here. Limits are the message and retention limits are determined by your Kafka configuration. So if you are familiar with the limits of Kafka today, you can set your own message and retention limits using the configuration itself. And also the storage, the amount of data that you store is going to be governed by the amount of storage that you have provisioned to the cluster. There are some service limits. There are two. There's a number, you have limits on the number of brokers per cluster and the number of brokers per account. Both of those are soft, so if you need more, just request a limit increase. In summary, what Amazon MSK does is it makes Apache Kafka more accessible to your organization. If you are not familiar with or skilled with running or taking ownership of operating the infrastructure required to run Kafka, Amazon MSK just made Kafka more available to you. That allows you as developers, as business owners, to develop applications that are closer to your end customers rather than spending time operating infrastructure that is undifferentiated. We're using best practices that we have learned through operating a massively scalable infrastructure over time through Kinesis data streams. We are taking best practices that are publicly noted through Kafka and making those defaults for the service. And we're driving automation into the infrastructure so that if there are issues, that we quickly detect and react to those immediately. Amazon MSK is also committed to improving open source Apache Kafka. That means the feedback that we get from you and from the feedback that we get from operating the service, we are going to take that feedback and enroll improvements back into the open source versions of Kafka So no matter who's running Kafka, if it's in Amazon MSK or not, they can take advantage of the contributions that we make over time. Here's a quick diagram on how connectivity works. This is also in our documentation. In summary, the resources themselves within MSK are running inside of a VPC in our account, and we make those resources available to your clients, your producers and consumers through ENIs. The resources in the cluster are not running in EC2, or you'll only see them in the Amazon VPC console. And at the same time, those resources themselves, your producers and consumers, are communicating to the brokers and over Elastic Network interfaces, which are not shown here. Here are some defaults that we are using out of the box during preview. You'll have more control over a lot of these defaults when the service is generally available. As I mentioned, pricing is Zookeeper and the data transfer in cluster is free, so you don't need to worry about being charged for those resources. Pricing is on demand and it's prorated to the second, so if you spin up and tear down a cluster within the hour, we're prorating the actual cost down to the second. Brokers and storage are the main resources for billing, and broker pricing starts at 21 cents an hour and storage starts at 10 cents per gigabyte month. This slide is designed to show you that the two technologies, Kinesis data streams and Kafka, are similar at the core of both. With Kinesis data streams, a stream is a logical grouping of shards, and each shard is effectively a commit or write-ahead log that allows you to write data to it. It is retained, and the data can be replayed in the order it was written. And the same with Kafka. Kafka, you have a topic, and that's a logical grouping of partitions, and the data can be replayed in the order it was generated, and it's also stored for a specific period of time. So that means there's overlap in the use cases for Amazon MSK and Amazon Kinesis data streams. You can run data streaming workloads on both. So when should you consider using one or the other? First, Amazon Kinesis data streams was designed for the cloud. It provides an AWS API experience. You can see that with an integration that we have with IAM, where each IAM call to the data plane, so each put and get is authorized through IAM. It offers a throughput provisioning model that allows you to right-size your streams to using incremental by adding incremental capacity on the order of 1 megabyte. So you can, if you have over time, if your streaming needs change, you can scale that capacity up and down and to closely match your needs. And what this means is most typically customers find that they can save money using Kinesis data streams over running Kafka, whether it's on their own or in the managed service for Kafka. And finally, Kinesis data streams has deep integrations with AWS. We're going to add integrations over time with Amazon MSK, and you've seen some of those already. But in the long run, a lot of those integrations are going to require some involvement with the community, which we can't necessarily control how long those contributions are going to take to make those integrations work. So in the long run, Kinesis data streams is likely going to have a head start and keep that keep that lead in terms of AWS integrations, but that doesn't mean that we're not going to provide deep integrations with Amazon MSK. Kafka has a number of advantages. One is it's open source compatible, so that if you're running Kafka in multiple environments, and in Amazon MSK or on-prem, your applications are compatible whether the clusters themselves are in AWS or not. It's also Kafka also provides strong third-party tooling. If you look at the frameworks and the tools and the number of technologies that are supported by Kafka, there's a wide array, and it also is if you look at Amazon MSK's provisioning model, it's cluster-based. So if you are adding capacity, you're provisioning effectively blocks of throughput. That is much larger than what you would be provisioning in Kinesis data streams. As I mentioned earlier, the scaling isn't seamless to the client. So if you're scaling up clusters of Kafka, as many of you probably know, that the scaling actions are not they're not seamless to producers and consumers working with Kafka. So you could see performance issues when scaling events occur. And also Kafka is highly configurable. So if you understand the knobs that Kafka provides, and you can actually tune Kafka to be very performant. While Kinesis Data Streams offers a performant experience, you can tune Kafka to achieve much higher performance. So why do we add Amazon MSK as an option for you? Well, first, we heard that our customers had Kafka applications, but they didn't want to run the actual underlying infrastructure because it detracted from their ability to build applications on top of Kafka. At the same time, we wanted to provide customers with an additional choice in the data streaming, managed data streaming options that they have at their disposal. We understand that it's not a one tool fits all workloads scenario. Many customers are using Kafka and Kinesis data streams at the same time. So we wanted to provide both customers, whether if they choose to use Kinesis or if they choose to use Kafka, a place to go. All right, that's it for the presentation. We're going to go ahead and take some questions over Q&A.